So this workshop is going to be on multiplying polynomials. Now before we start, we should probably go over what the definition of a polynomial is. And it's an expression consisting of variables and coefficients that involves only the operations of addition, subtraction, multiplication, and non-negative integer exponents. Now that sounds like a lot, but it won't seem so bad once you see what it is. So we have variables and coefficients and non-negative integer exponents, and we only use addition, subtraction, and multiplication. So for example, 2x squared minus 10x plus 4 is a polynomial. We have the coefficients, we have our variable only raised to integer powers, because without an exponent would be x to the first. So this would be a polynomial. And in fact, it's a trinomial because it has 3 terms. X plus 4 would be a polynomial. It has 2 terms, so it is in fact a binomial. 2 terms. But for example, let's say we had 3x to the negative 4th power plus 5x minus 7. This would not be a polynomial. And it is not a polynomial because we have x raised to a negative power. And in our definition, it says we can only have non-negative exponents. So, not a polynomial. So let's go over how we would multiply 2 polynomials together. A situation where you might have to do this is if you were converting a quadratic function into standard form, and it was in vertex form or factored form. So let's say we had the function f of x equals x minus 3 times x plus 4. And we're going to convert it into standard form. Now one way you could do this is using a technique that is colloquially referred to as FOIL. This is where you multiply the first terms and the outer terms, inner terms, and the last terms. And this does happen to work in any case that is a binomial multiplied by another binomial. So x times x gives us x squared, x times 4 gives us plus 4x, negative 3 times x gives us minus 3x, negative 3 times 4 gives us negative 12. Then we combine like terms, so a 4x minus 3x gives us x squared minus 1x minus 12. Remember, if it's a 1x, you don't have to write the coefficient. Now that is one way to multiply 2 polynomials. If you're comfortable with doing that, then by all means use it. I just don't like using the word FOIL to describe multiplying 2 polynomials. FOIL is what I wrap my breakfast tacos in when I want to keep them warm. But FOIL, to me, you lose the fact that you're multiplying. And it's important when you're doing math to be able to recognize what you're doing. So if you use FOIL as a trick, by all means do it if it helps you. But I prefer to think of it as you're multiplying, because that's exactly what you're doing. And in fact, I want to show you another way you can multiply these two binomials. And it's exactly the same way that you would multiply 2 numbers. So you can line them up vertically like this. X minus 3 times x plus 4. I'll put a dot out there because we're multiplying. And let's compare this with how we would multiply 31 and 22, right? If I was multiplying 31 and 22 the long way by hand, I would do 2 times 1 is 2, 2 times 3 is 6. I'm going to do the same thing over here. 4 times 3 is negative 12, and 4 times x is 4x. Then you leave a space down here where you put a 0. 2 times 1 is 2, 2 times 3 is 6. And you add straight down. 682. Same thing over here. I'm going to leave a space here. And then x times negative 3 is minus 3x. X times x is x squared. And I add down. Notice I left the space so that my like terms lined up. Negative 12 plus 0 is negative 12. 4x minus 3x is 1x. And then x squared just drops down. Now notice this is positive 4x minus 3x, so that's plus 1x. We get the same thing, right? Whichever way you choose to multiply your two binomials together, it doesn't matter so much to me. I like doing it this way. I feel like it just keeps things more organized and I keep track of my terms better. But by all means, if FOIL is what you're comfortable with, then do it that way. For now. Because you can. So let's try another one. Let's say this time we have 2 times x minus 3. Let's make that a negative 2. And 2x plus 5. Now, there's two ways you can go about doing this. Just keep in mind, the negative 2 is only going to be multiplied by something once. So when I see a coefficient in front, and remember, it doesn't matter what order you multiply in, because multiplication is commutative, just like we did way back in the beginning of the year. So I'm first going to worry about my two binomials. All right? So I'm going to multiply those two. You can use FOIL. I'm going to do it vertically. I just like that way better. 2x plus 5 times x minus 3. Negative 3 times 5 is negative 15. Negative 3 times 2x is negative 6x. X times 5 is 5x. And x times 2x is 2x squared. And then we add down, so negative 15 stays by itself. Negative 6x plus 5x, that's a negative 1x. And then 2x squared. Now, I've multiplied this 2, but I still have the negative 2 out in front. So now I have negative 2 times 2x squared minus x minus 15. Now I just need to distribute the negative 2. So negative 2 times 2x, negative 4x squared. Negative 2 times negative x is going to be plus 2x. Negative 2 times negative 15 is going to be plus 30. So there is my final standard form of this quadratic. Let's look at another example where the quadratic is in vertex form. So let's say we had, I'll put a coefficient out here, 4 times x minus 4 quantity squared. Let's say there's a minus 3 off at the end. So this would be a quadratic function with a vertex at positive 4, negative 3, right? And let's say we wanted to convert this to standard form. Now, what I see a lot of the time is you want to distribute this 4. But remember, if you're following the order of operations that you learned way back in the day, we have an exponent. And exponents come before multiplication because distributing into a set of parentheses is multiplication. So we need to deal with this exponent first, right? So, now, how do you deal with the exponent? Well, you have to remember, what does it mean to square something? We have to multiply it by itself. So, this is now 4 times x minus 4 times x minus 4, and then minus 3. Right? Exponents do not distribute into parentheses like constant numbers do, because you have to remember that it's an exponent. That means you're multiplying it by itself. So we multiply x minus 4 and x minus 4. For this one, I'll use FOIL for all you fans of FOIL out there. So I'm going to have x squared minus 4x minus another 4x, and then plus 16, and all minus 3. Then I'm going to combine like terms in here. So I still have the 4 out front. So it's x squared minus 8x plus 16 minus 3 off at the end. Now I'm going to distribute the 4. So I have 4x squared minus 32x, 16 times 4 is, I think, 48. Yeah. And then minus 3. And then 48 minus 3 is just 45. So finally, in vertex, or in standard form, we have 4x squared minus 32x plus 45. And remember, there is a reason to want to convert to standard form. So vertex form tells us the vertex, but standard form tells us the y-intercept. So from here, we can see this quadratic function has a vertex at positive 4, negative 3. After converting it to standard form, we can see that it has a y-intercept at positive 45. And another reason is that in order to convert it to its factored form, you're going to have to end up going through your standard form first. Let's do one last example of multiplying two polynomials. This one's going to be a little bit hard. So let's say we wanted to simplify x plus 3 times x squared minus 3x plus 7. Now, can we use FOIL? The answer is going to be no. We have a binomial times a trinomial. When we have that, FOIL gets thrown out the window because there's no m in FOIL. There's no middle terms. So these we have to line up vertically. So we have x squared minus 3x plus 7 all times x plus 3. All right? So 7 times 3 is 21. And one thing that's a little bit different is you don't have to worry about, carrying. So 7 times 3 is 21. You just drop the 21. 3 times negative 3x is going to be a negative 9x. And then 3 times x squared is 3x squared. Remember to leave that space. The space just really helps you combine your like terms. Because the next term is going to be x times 7, which is 7x. X times negative 3x, which is negative 3x squared. And then x times x squared. Remember, if you have x and then times x again, that's going to be an x to the third power. Then we just combine our like terms vertically. So 21 plus 0 is 21. Negative 9x, that's a plus 7x, is going to be negative 2x. 3x squared minus 3x squared, well, that's convenient. That's 0. That helps. You can write an x squared. And then where x cubed just drops straight down. So altogether, since it's a 0x squared, we're not going to write it anymore. We would have x to the third power minus 2x plus 21 is our final simplified version. So it is important to know how to multiply vertically because if you wanted to, you can only use FOIL in the special case of a binomial times a binomial. Here we have a binomial times a trinomial, so we do have to line them up vertically. All right, that is going to conclude this workshop on multiplying polynomials.